In this video, we are gonna solve mathematics ESSLCE of the year 2013-2014 Ethiopia calendar. Here are the questions. Question number 1. What's the determinant of a 2 by 2 matrix having elements of first row 1, -7 and elements of second row 6, 5? To solve this problem, multiply elements at the top left by elements at the bottom right and then deduct the products of elements at the bottom left and the top right from the first product. Thus, the determinant of a matrix under inquiry is equal to 1 times 5 minus 6 times -7. 1 times 5 is 5 minus 6 times -7 is -42. 5 minus -42 is equal to 5 plus 42 because the product of two negatives is positive. Then 5 plus 42 is equal to 47. So choice A is the answer. Question number 2. The additive inverse of a complex number 3 minus 4i is A. 3 minus 4i, B. -3 plus 4i, C. 3 plus 4i, D. -3 minus 4i. As we know, additive inverse is a number added to a given number to make the sum 0. Let Z is the additive inverse of 3 minus 4i, hence Z plus 3 minus 4i is equal to 0. The expression 3 minus 4i has to be taken to the right side to solve for Z. When we take the expression 3 minus 4i to the other side of equality sign, the positive term becomes negative and the negative term becomes positive. So the equation becomes Z is equal to -3 plus 4i. Thus, choice B is the answer. Question number 3. What is the modulus of a complex number -6 plus 8i? Modulus refers to length of line joining the origin to a particular point. For ease of visualizing the point where -6 plus 8 are lie, let's draw the graph in the complex plane. In the complex plane, the vertical axis represents the imaginary part and the horizontal axis represents the real part. So the graph looks like this. In the equation -6 plus 8i, -6 represents the real part that is located 6 units to the left of the origin, and 8 represents imaginary part that's located 8 units above the origin. Thus, the modulus is the hypotenuse of the vertical imaginary line and the horizontal real line that can be calculated by using the formula modulus square is equal to 6 square plus 8 square. 6 square is 36 plus 8 square is 64. 36 plus 64 is equal to 100. Thus modulus is equal to 10. So choice A is the right answer. Question number 4. What are the modulus and argument of a complex number 2 plus 2i respectively? We already discussed modulus in question number 3 above. Now let's define what argument means. Argument is an angle inclined from a real axis in the direction of the complex number represented on a complex plane. Once again, let's draw the graph for ease of understanding the modulus and argument. The graph looks like this. The modulus M is the hypotenuse and the argument is angle theta. Modulus M or hypotenuse is calculated by using the formula m square is equal to 2 square plus 2 square. 2 square is 4 plus again 2 square is 4. 4 plus 4 is 8. So modulus is equal to 2 root 2. The angle tan theta is equal to opposite over adjacent. The opposite is 2 divided by the adjacent is again 2. 2 divided by 2 is 1. So theta is equal to pi over 4. Therefore, the modulus and argument respectively are 2 root 2 and pi over 4. Choice C is the correct answer. Question number 5. Given two vectors u is equal to 1, 3 and v is equal to -3, 5 in the plane, then 6u plus 2v is equal to A 2,28, B 0,28, C 0,18, D 3,3. The rules concerning multiplication of vector by scalar and addition of vectors in a Cartesian coordinate are important for solving this problem. In multiplying vector by scalar, multiply each component by the scalar. If u is equal to the scalar c times a sub 1, a sub 2, then the constant c has to be distributed to the steps inside the bracket. So the result will be c times a sub 1, c times a sub 2. In adding vectors, the first component of vector 1 must be added to the first component of vector 2, and the second component of vector 1 with the second component of vector 2. If a sub 1, a sub 2 is the first vector, and b sub 1, b sub 2 is the second vector, then their sum is a sub 1 plus b sub 1, a sub 2 plus b sub 2. Then the inquiry 6u plus 2v is equal to 6 times the order pair of u, that's 1, 3, plus 2 times the order pair of v, that's negative 3, 5. 6 times 1 is 6, 6 times 3 is 18, plus 2 times negative 3 is negative 6, 2 times 5 is 10, 6 plus negative 6, 18 plus 10. That is the first component with first added with first component, and second component added with second component. 6 plus negative 6 is 0. 18 plus 10 is 28. So choice B is the answer. Question number 6. Which one of the following is the standard form of equation of a circle centered at 2, negative 3 and radius 5? The standard form of equation of a circle is given by x minus h the whole square plus y minus k the whole square is equal to r square, where h, k order pair for the center of a circle and r is a radius. By plugging in 2, negative 3 and 5 in their appropriate position, we will find x minus 2 the whole square plus y minus negative 3 the whole square is equal to 5 square. This implies x minus 2 the whole square plus y minus negative 3 means y plus 3 the whole square is equal to 5 square is 25. So choice D is the right answer. Question number 7. If small letter f is a continuous function on a closed bounded interval a, b, and capital letter F is its antiderivative, then which one of the following is true? A. Integral of small letter f of x d of x, where x ranging from a to b is equal to capital letter f of b minus capital letter f of a. B. Integral of f derivative of x dx, x ranging from a to b is equal to capital letter f of b minus capital letter f of a. C. Integral of derivative of capital letter f of x ranging from a to b is equal to small letter f of b minus small letter f of a. D. Integral of capital letter f of x d of x ranging from a to b is equal to small letter f of b minus small letter f of a. We know from the fundamental theorem of calculus that if small letter f is continuous over a closed bounded interval a, b, and capital letter f of x is any antiderivative of f of x, then the integral of small letter f of x d of x from ranging from a to b is equal to capital letter f of b minus capital letter f of a. So choice A is the answer. Question number 8. Which of the following defines equation of a sphere whose center is at 0, negative 1, 2 and radius is 6 units? The equation of sphere whose center at a, b, c and the radius r is given by x minus a the whole square plus y minus b the whole square plus z minus c the whole square is equal to r square. By plugging in 0, negative 1, 2 in their appropriate position, we will find x minus 0 the whole square plus y minus negative 1 the whole square plus z minus 2 the whole square is equal to 6 square. X minus 0 is x, so x square plus y minus negative 1 means y plus 1 the whole square, because the product of two negatives is positive, plus z minus 2 the whole square is equal to 6 square is 36. So choice C is the answer. Question number 9. Which one of the following represents vector 3, negative 5, 7 in the space using a standard unit vectors I, j and k? A. 3i minus 5j plus 7k. B. Negative 3i minus 5j minus 7k. C. 3i minus 5j minus 7k. D. 3i plus 5j plus 7k. Instead of representing vectors as a list of components in space, they can be rewritten as a sum of standard unit vectors as x, y, z is equal to x times unit vector I plus y times unit vector j plus z times unit vector k. Thus, 3, negative 5, 7 can be rewritten in terms of unit vectors I, j, k as 3, negative 5, 7 is equal to 3 times unit vector I plus negative 5 times unit vector j plus 7 times unit vector k. This gives us 3i minus 5j plus 7k. Choice A is the answer. Question number 10. Which one of the following is a scalar or dot product of vector 2, negative 4, 6 and negative 2, negative 1, 0? The scalar or dot product of two vectors is the sum of the product of the corresponding components of the vectors. If a sub 1, a sub 2, a sub 3 and b sub 1, b sub 2 and b sub 3 are two vectors, their dot product is equal to a sub 1 times b sub 1 plus a sub 2 times b sub 2 plus a sub 3 times b sub 3. So, by the same analogy, the scalar or dot product of vectors 2, negative 4, negative 6 and negative 2, negative 1, 0 gives 2 times negative 2 plus negative 4 times negative 1 plus 6 times 0. 2 times negative 2 is negative 4 plus negative 4 times negative 1 is 4 plus 6 times 0 is 0. Negative 4 plus 4 is 0 plus 0 is 0. So the answer is 0. Choice C is the answer. What are the domain and range of a function f of x is equal to 2x the power of 3 over 4 respectively? 2x the power of 3 over 4 can be rewritten as 2 times x cubed the whole raised 1 over 4, which is equal to 2 times the fourth root of x cubed. Whenever the index number is even, the radicand or the stuff inside the radical must be greater than or equal to 0. Thus, x cubed must be greater than or equal to 0. This implies x greater or equal to 0. So, the domain is 0, infinity. 0 is included. If x ranges from 0 to infinity, then f of x is equal to 2 times the fourth root of x squared is either positive or 0. Hence, the range is also 0 to infinity. The range is also 0, infinity. 0 is also included because it's close bounded interval. The answer is choice B. Question number 12. Which one of the following defines a one-to-one function? A function f is one-to-one if every element of the range of f of x corresponding to exactly one element of the domain of f. Let's analyze each choice with respect to this definition. Choice A, f of x is equal to order pair xy such that y is equal to x squared plus 1. Let negative 1, positive 1, negative 2 and 2 are chosen as a domain over this function. So the range is calculated as the square of domain plus 1. Negative 1 square is 1, 1 plus 1 is 2. 1 square is again 1, 1 plus 1 is 2. Negative 2 square is 4, 4 plus 1 is 5. 2 square is 4 again, 4 plus 1 is 5. This means one element of the range corresponding to two elements of the domain. So the function is not one-to-one. Choice B, f is equal to order pair xy such that y is a father of x. Let sun A, girl B and sun C are a domain of this function and father y is the range. Father y is the father of sun A, girl B and sun C, meaning one element of the range corresponding to three elements of the domain. So the function is not one-to-one. Choice C, f of x is equal to order pair xy such that x is a sister of y. Let Miss X and Miss Y are the domain and Mr. Z is the range. Miss X and Miss Y are sisters of Mr. Z, meaning one element of a range corresponding to two elements of the domain. So f is not one-to-one. In choice D, that's f is equal to order pair xy such that y is equal to 3x minus 1, which is linear equation. It's impossible to find more than one y for a single x. Hence, f is one-to-one function. Generally, all linear functions are one-to-one function. Thus, the answer is choice D. Question number 13. The equation of a circle is given by x minus 3 the whole square plus y plus 2 the whole square is equal to 9. So the question is, what are the center and the radius of the circle representatively? Equation of a circle is given by the formula x minus h the whole square is plus y minus k the whole square is equal to r square, where h comma k is the center and r is the radius. X minus 3 the whole square plus y plus 2 the whole square is equal to 9 can be rewritten as x minus 3 the whole square plus y minus negative 2 the whole square is equal to 3 square. So from this expression we can learn that the center is 3 comma negative 2 and the radius is 3. So choice C is the answer. Question number 14. Which one of the following sentences has a truth value? A. Man is mortal. B. Tomorrow is a beautiful day. C. Man is selfish. D. We shall win. Sentences that have a truth value are those that are either true or false, but not both. In this case, except choice A, it's difficult to judge the other sentences as true or false because they are simply expressing personal opinions or goodwills. So the right alternative is choice A. Question number 15. Which one of the following is the standard form of equation of the parabola with vertex 4, 6 and the focus negative 8, 6? From the givens vertex 4, 6 and the focus negative 8, 6, we can figure out the following. 1. Since the second coordinate of both vertex and focus is 6, the axis of symmetry is the horizontal axis, that's y is equal to 6. Second, whenever the axis of symmetry is horizontal, the standard form of equation of the parabola is given by y minus k the whole square is equal to plus or minus 4p times x minus h, where h comma k is the vertex of and p, where h comma k is the vertex and p is the distance from vertex to the focus. P can be calculated by using vertex 4, 6 and the focus negative 8, 6 as p is equal to the square root of negative 8 minus 4 the whole square plus 6 minus 6 the whole square. Negative 8 minus 4 is negative 12. Negative 12 square is 144 plus 6 minus 6 is 0. 0 square is 0. The square root of 144 is equal to 12. Since the focus, which is a point inside the parabola, is to the left of the vertex, the parabola opens to the left. So the equation of the parabola became y minus 6 the whole square is equal to negative 4 times 12 times x minus 4. This implies y minus 6 the whole square is equal to negative 4 times 12 is minus 48 times x minus 4. We use the sign negative here because we figure out that the parabola opens to the left. So choice B is the correct answer. Question number 16. Which of the following is true about hyperbola given by the equation x squared over 4 minus y squared is equal to 1? A. Its center is at 2, 1. B. An asymptote to the hyperbola is y is equal to 2x. C. Its foci are negative 5, 0 and 5, 0. D. Its vertices are negative 2, 0 and 2, 0. We know that the equation of the hyperbola its center at h, k is given by the formula x minus h the whole square over a square minus y minus k the whole square over b square is equal to 1 for horizontal hyperbola, and y minus k the whole square over a square minus x minus h the whole square over b square is equal to 1 for vertical hyperbola. Then the given equation can be rewritten as x minus 0 the whole square over 2 square minus y minus 0 the whole square over 1 square is equal to 1. Hence, the center is 0, 0. So choice A is false. Second, since the positive term is x, the given hyperbola is a horizontal hyperbola. The asymptotes of a horizontal hyperbola are given by the equation y is equal to plus or minus b over ax. From the given equation, we can determine that a is equal to 2 and b is equal to 1. Thus the equations of asymptotes of a hyperbola are y is equal to plus or minus 1 over 2x. This implies y is equal to negative 1 over 2x and y is equal to 1 over 2x are equations of the asymptotes. So choice B also false. Third, the length of foci C in terms of the length of transverse axis A and the length of conjugate axis B is given by the formula c square is equal to a square plus b square. This implies C is equal to plus or minus root of A square plus B square. C is equal to plus or minus square root of A square is 4 plus B square is 1. 4 plus 1 is 5. So C is equal to plus or minus square root of 5, meaning the foci are located root 5 unit to the left and root 5 unit to the right of the center 0, 0. So the order pair of the two foci are negative root 5, 0 and positive root 5, 0. So choice C is also false. The vertex of the horizontal hyperbola having center at the origin is given by the formula plus or minus A, 0. Thus, the vertex of the hyperbola are plus or minus 2, 0 or negative 2, 0 and 2, 0 are the vertex of the hyperbola. So choice D is true, or choice D is the right answer. Question number 17. Two statements P and Q are given by P is equal to 22/7 is an irrational number and Q is equal to the sum of two odd numbers is odd. Then, which one of the following has a truth value of true? A. Negation of P and Q. B. P and Q. C. P and negation of Q. D. P or negation of Q. P is equal to 22/7 is an irrational number is false, because 22/7 is a rational number. If 2 plus 1 represent an odd integer, then Q is equal to the sum of two odd integers is given by the formula 2n plus 1 plus 2n plus 1. 2n plus 2n is 4n plus 1 plus 1 is 2. So 4n plus 2 can be rewritten as 2 times 2n plus 1. If any integer is multiplied by 2, the result is even. This implies that Q is false. Hence, negation of P and Q is equal to P is false, then negation of P is true, and Q is false. True and false is false. Thus, choice A has a truth value of false. P and Q is equal to P is false and Q is false. False and false is equal to false. So choice B has a truth value of false. P and negation of Q is equal to P is false and Q is false, then negation of Q is true. False and true is equal to false. Thus choice D has a truth value of false. P or negation of Q is equal to P is false or negation of Q is true. P or true, false or true is equal to true. Choice D has a truth value of true. Thus the correct answer is choice D. Question number 18. Which one of the following is contrapositive of a statement? If 21 is a prime number, then 4 is an odd number. By definition, negation of Q implies negation of P is the contrapositive of P implies Q. From the statement, 4 is an odd number, represent Q. So negation of Q is equal to 4 is not an odd number. P represents the sentence 21 is a prime number. Then negation of P is equal to 21 is not a prime number. Thus, negation of Q implies negation of P can be written as if 4 is not an odd number, then 21 is not a prime number. Therefore, the contrapositive of a statement if 21 is not a prime number, then 4 is an odd number is if 4 is not an odd number, then 21 is not a prime number. So the correct answer is choice A. Question number 19. Consider the following frequency distribution table. Values: 5, its frequency is 3, 3, its frequency is 4, 7, its frequency is 5, 6, its frequency is 3, and 8 with its frequency 5. Then what is the 6th decile? The following are the steps to solve this problem. Step 1. Rearrange the frequency distribution table with increasing order of values. So the table becomes value 3 with its frequency 4, value 5 with its frequency 3, value 6 with its frequency 3, value 7 with its frequency 5, and value 8 with its frequency 5. Second, calculate the total number of observations as summation of f, where f is the frequency of distribution. That is, total observation is equal to summation of frequency, which is equal to 4 plus 3 plus 3 plus 5 plus 5. The sum of these numbers is 20. Third, since the total number of observations is even, the ith decile is calculated by using the formula d sub I is equal to I times n divided by 10 plus I times n divided by 10 plus 1, the whole over 2's item, where I is equal to the ith decile and n is equal to total number of observations. Thus, the sixth decile, d sub 6 is equal to 6 times 20, that's total number of observation, divided by 10, plus 6 times 20 divided by 10 plus 1, the whole over 2. 0 cross out by 0, so 2 times 6 is 12. Again here 0 cross out by 0, 6 times 2 is 12, plus 1, the whole over 2. 12 plus 1 is 13, so 13 plus 12 is 25, the whole over 2, which is equal to 12.5 item is the 6th decile, meaning the 6th decile is halfway between 12th and 13th item of the frequency distribution arranged in increasing order of values. So d sub 6 is equal to 12th item plus 13th item minus 12th item times 0.5. 12th item and 13th item are determined by adding frequency starting from the smallest value until we find the sum 12 and 30. Hence, 4 plus 3 plus 3, that is the sum of the 3 values, is equal to 10, which is less than 12. If we add 5, we find 15, meaning items from 11th to 15th are represented by 7. So that is 12th item is equal to 7 and 13th item is equal to 7. Thus, the 6th decile, that is d sub 6, is equal to 12th item is 7 plus 13th item is 7 minus 12th item, that's 7 times 0.5. 7 minus 7 is 0 times 0.5 is 0. So 7 plus 0 is equal to 7. The correct answer is choice B. In a certain health center, there are 3 doctors, 8 nurses and 2 physicians. In how many ways one can form a group of 5 members containing 1 doctor, 3 nurses and 1 physician? The order of selecting 1 doctor from 3, 3 nurses from 8 and 1 physician from 2 doesn't matter. Hence, it's appropriate to use comparison for selecting 5 members containing 1 doctor, 3 nurses and 1 physician. Hence, total number of ways of selecting 5 members is equal to combination of 3, 1 times combination of 8, 3 times combination of 2, 1. Combination of 3, 1 is equal to 3 prime divided by 3 minus 1 prime times 1 prime times combination of 8, 3 is equal to 8 prime divided by 8 minus 3 prime times 3 prime. Combination of 2, 1 is equal to 2 prime divided by 2 minus 1 prime times 1 prime. 3 prime can be rewritten as 3 times 2 prime. We left 2 prime as it is because we have 2 prime in the denominator, so they can cross out each other. 8 prime can be rewritten as 8 times 7 times 6 times 5 prime. Again, we will left 5 prime as it is because we have in the denominator 5 prime, that is 8 minus 3 prime. Then 5 prime will cross out by 5 prime. And 3 prime can be rewritten as 3 times 2 times 2 prime is 2 times 1 divided by 2 minus 1 prime is 1 prime times 1 prime. In the first expression, that's 3 times 2 prime divided by 2 prime times 1 prime. 2 prime cross out by 2 prime, we left with 3 times 8 times 7 times 6 times 5 prime divided by 5 prime. 5 prime will cross out by 5 prime. 3 prime means 3 times 2 times 1. 3 times 2 is 6. 6 cross out by 6. So we left is 8 times 7. Times in the third expression, 2 times 1 is 2 divided by 1 prime is 2. So we left with 3 times 8 times 7 times 2. So their product is 336. So the answer is choice A. Question number 21. Which one of the following forms represent an exhaustive set of events if a die is thrown once? Exhaustive set of events is an event containing all the possible outcomes of the probability. Hence, if a die is thrown once, The possible outcomes are 1, 2, 3, 4, 5, 6. In choice A, the possible outcome 3 is missed. In choice B, the possible outcome 5 is missed. In choice C, the possible outcome 3 is again missed. Choice D include all the possible outcomes, so alternative D is the right answer. Question number 22. A bag contains 2 red, 3 yellow and 5 green balls. One ball is drawn at random. What is the probability that the drawn ball is not yellow? If the ball drawn is not yellow, then it is either red or green. Hence, the probability of being red or green can be determined as a sum of the probability of being red and the probability of being green. So probability of being red or green is equal to probability of red plus probability of green. The probability of red is equal to the number of red, that is 2, divided by the total number of balls, that's 10, plus probability of green is equal to the number of green balls, that is 5, divided by the total number of balls, that's 10. 2 over 10 plus 5 over 10 is equal to 7 over 10. So the answer is B. Which one of the following is a product of the product AB of two matrices? A is equal to a 2 by 2 matrix having elements of first row negative 2 and 3 and elements of second row 1, 4, and B is equal to a 2 by 2 matrix having elements of first row negative 1 and 5 and elements of second row 3 and 0. A times B, that's the product of the two matrices, can be determined by following the steps below. To multiply these two matrices, first determine the sum of the product of first row of A with the corresponding first column of B, that is 2 times negative 1 plus 3 times 3. Then the second step, determines the sum of the product of first row of A with the corresponding second column of B, that's negative 2 times 5 plus 3 times 0. Third, determines the sum of a product of second row of A with the corresponding first column of B, that's 1 times negative 1 plus 4 times 3. Finally, determines the sum of a product of second row of A with the corresponding second column of matrix B, that's 1 times 5 plus 4 times 0. Negative 2 times negative 1 is 2 plus 3 times 3 is 9. Negative 2 times 5 is negative 10 plus 3 times 0 is 0. 1 times negative 1 is negative 1 plus 4 times 3 is 12. 1 times 5 is 5 plus 4 times 0 is 0. 2 plus 9 is 11. Negative 10 plus 0 is negative 10. Negative 1 plus 12 is 11. 5 plus 0 is 5. So the answer is a 2 by 2 matrix having elements of first row 11, negative 10 and elements of second row 11, 5. That's choice A is the right answer. Question number 24. Which one of the following is not true about a determinant of a given square matrix? A. The determinant of A is equal to the determinant of its transpose. B. Interchanging two rows of A gives the same determinant. C. If A contains a row of zeros, then the determinant is 0. D. If A has identical rows, then its determinant is 0. To reply this question, let's see some of properties of a square matrix by referring appropriate examples. 1. The determinant of a square matrix is equal to the determinant of its transpose. Let A is equal to a 2 by 2 matrix having elements of first row 3, 5 and elements of second row 4, 7. Its transpose is A transpose, which is determined by exchanging rows and columns. That is, first row becomes first column and second row becomes second column. Determinant of A is equal to 3 times 7 minus 4 times 5, which is equal to 3 times 7 is 21, minus 4 times 5 is 20. 21 minus 20 is 1. Determinant of the transpose, that's 3 times 7 minus 4 times 5. 3 times 7 is 21, minus 5 times 4 is 20. 21 minus 20 is 1, meaning determinant of A is equal to determinant of A transpose, so choice A is true. Second, if a determinant is found by interchanging two rows or columns, the determinant of the new matrix is equal to the negative of the determinants of the old matrix. If A is a 2 by 2 matrix having elements of first row 3, 5 and second row 4, 7, then by interchanging row 1 and row 2, we will find a matrix B, which is a 2 by 2 matrix having first row elements 4, 7 and elements of second row 3, 5. Determinant of A is equal to 1, which is already calculated above. Determinant of B is equal to 4 times 5 minus 3 times 7. 4 times 5 is 20, minus 3 times 7 is 21. 20 minus 21 is negative 1, meaning determinant of A is equal to negative of determinant of B. Thus choice B is not true. Third, if a square matrix has a row or column of 0, then its determinant is 0. Let's take A is a square matrix having 3 rows and 3 columns. Elements of first row is equal to 3, 5, 2. Elements of second row 4, 7, 6. And elements of third row 0, 0, 0. In this matrix, row 3 is 0 row. Then determinant of A is equal to first element of row 1, that is 3. We will cross out row 1 and column 1. We left with 7 times 0 minus 6 times 0 minus elements of second elements of first row, that's 5. We will cross out first row and second column, then we left with 4 times 0 minus 6 times 0 plus third elements of first row, that is 2 times. We will cross out first row and third column, then we left with 4 times 0 minus 7 times 0. 7 times 0 is 0, minus 6 times 0 is 0, so 0 minus 0 is 0. We left here with 3 times 0, minus 5 times. 4 times 0 is 0, minus 6 times 0 is 0. 0 minus 0 is also 0, plus 2 times. 4 times 0 is 0, minus 7 times 0 is 0. 0 minus 0 is also 0. 3 times 0 minus 5 times 0 plus 2 times 0, their sum is 0. So choice C is also true. The fourth property of a square matrix: if a square matrix has identical rows or columns, then its determinant is 0. Let a matrix C is a 3 by 3 matrix having elements of first row 3, 5, 3, elements of second row 4, 7, 4, and elements of third row 1, 2, 1. In this matrix, column 1 is equal to column 3. Then determinant of C is equal to first elements of row 1, that's 3 times. We will cross out row 1 and column 1. Then we left with 7 times 1 minus 4 times 2 minus second elements of row 1, that's 5 times. When we take the second elements of row 1, we will cross out row 1 and column 2. Then we left with 4 times 1 minus 4 times 1 plus third element of row 1, that's 3 times. Again here we will cross out row 1 and column 3. We left with 4 times 2 minus 7 times 1. 7 times 1 is 7, minus 4 times 2 is 8. 7 minus 8 is negative 1. Minus 5 times 4 times 1 is 4, minus 4 times 1 is 4. 4 minus 4 is 0, plus 3 times 4 times 2 is minus 7 times 1 is 7. 8 minus 7 is 1. 3 times negative 1 is negative 3. Minus 5 times 0 is 0. Plus 3 times 1 is 3. Negative 3 plus 3 is 0. 0 minus 0 is 0. Thus choice D is also true. So the answer is choice B, because as we checked in Roman number 2 above, interchanging two rows of A gives a negative of determinant of the old one, but not equal. Question number 25. Which one of the following is the inverse of the matrix? That's a 2 by 2 matrix having elements of first row 2, 3 and elements of second row 3, 4. As we know, a matrix times its inverse is equal to an identity matrix. Then let A, B, C, D is the inverse of the matrix under inquiry. Then the product of the two matrices, that is matrix with an element AB in first row and CD in second row times the matrix under inquiry, that's 2, 3, 3, 4, is equal to 1, 0, 0, 1. That's an identity matrix. So multiplying these two matrices gives, in multiplying these two matrices, first determine the sum of the product of row 1 of the left side matrix with the corresponding column 1 of the matrix under inquiry, that is 2a plus 3b. Again, determine the sum of the product of row 1 of the inverse matrix with the corresponding second column of the matrix and under inquiry, that is 3a plus 4b. Again, determine the sum of the product of second row of the inverse matrix with the corresponding column 1 of a matrix under inquiry, that is 2c plus 3d. Again, determine the sum of the product of row 2 of the inverse matrix times with the corresponding second column of the matrix under inquiry, that's 3c plus 4d, is equal to the identity matrix. From the equality of the two matrices, we can find that second element of row 1 of the matrix at the left is equal to second element of row 1 of the matrix at the right, that is 3a plus 4b is equal to 0. This equation can be rewritten as b is equal to negative 3 over 4a. Again, the first element of row 1 of a matrix at the left is equal to the first element of row 1 of a matrix at the right, meaning 2a plus 3b is equal to 1. Substituting negative 3 over 4a in place of b, we will find 2a plus 3 times negative 3 over 4a is equal to 1. This implies 2a minus 3 times 3 over 4 is equal to negative 4 over 4a is equal to 1. 2a can be rewritten as 8 over 4a, just to make the denominator similar with the second expression, that's negative 9 over 4a. So 8 over 4a minus 9 over 4a is equal to 1. 8 over 4 minus 9 over 4 is negative 1 over 4. A is equal to 1, meaning a is equal to negative 4. B can be calculated by using the value of a as b is equal to negative 3 over 4 times the value of a, that's negative 4. 4 is crossed out by 4, so we left with negative 3 times negative 1. Negative 3 times negative 1 is equal to positive 3. Again, from the equality of the two matrices, we can learn that first element of second row of a matrix at the left is equal to first element of second row of a matrix at the right. That is 2c plus 3d is equal to 0, meaning c is equal to negative 3 over 2d. Again, second element of second row of a matrix at the left is equal to second element of second row of a matrix at the right. That means 3c plus 4d is equal to 1. Substituting negative 3 over 4d in place of c, we will find 3 times negative 3 over 2d plus 4d is equal to 1. 3 times negative 3 over 2 is negative 9 over 2 plus 4d is equal to 1. 4d can be rewritten as 8 over 2, just to make the denominators of the two expressions at the left similar. Thus, negative 9 over 2d plus 8 over 2d is equal to 1. Negative 9 over 2 plus 8 over 2 is negative 1 over 2, d is equal to 1, meaning d is equal to negative 2. So, c can be calculated as c is equal to negative 3 over 2d. Substituting negative 2 in place of d, we will find c is equal to negative 3 over 2 times negative 2. 2 cross out by 2. So, negative 3 times negative 1 is 3. Therefore, the inverse matrix A, B, C, D can be written as A is negative 4 and B is 3, C is 3 and D is negative 2. So the correct answer is D. This method is a bit tedious and time consuming. We have a simple formula for determining the inverse of a 2 by 2 matrix. That is, if A is equal to A, B, C, D is a 2 by 2 matrix, then the inverse of A is calculated by using the formula 1 over the determinant of the matrix A times this matrix, that is switching D and A, and then multiplying the two elements, that's second element of first row and first element of second row by negative. By using this formula, the inverse can be calculated. The inverse of the matrix under inquiry can be calculated as the matrix is a 2 by 2 matrix having first row element 2, 3 and second row element 3 and 4, which is equal to 1 over the determinant of this matrix, that is 2 times 4 minus 3 times 3 times the inverse of the matrix, that's switching 2 and 4, we will find 4, 2, and multiplying second element second element of first row and first element of second row by negative, we will find negative 3 and negative 3 here. 1 over 8 minus 9 is 1 over negative 1 times first row element 4 negative 3 and second row element negative 3 2, which is equal to negative 1 times 4 is negative 4, negative 1 times negative 3 is 3, negative 1 times negative 3 is 3, negative 1 times 2 is negative 2. The answer is choice D again. Question number 26. Consider the system of linear equation ax minus ay is equal to 1 and 6x plus 4y is equal to 5. Then which one of the following is true? A. If a is equal to 2, then the system has no solution. B. If a greater than 2, then the system has infinitely many solutions. C. If a greater than negative 2, then the system has a unique solution. D. If a is equal to negative 2, then the system has a unique solution. That equation can be rewritten as y is equal to 3 over ax minus negative 1 over a. And the second equation can be rewritten as y is equal to negative 3 over 2x plus 5 over 4. The system has no solution only when the two lines are parallel. That is only when the slope of the two lines are equal. The slope of the first line is 3 over a. The second equation is negative 3 over 2. So if 3 over a is equal to negative 3 over 2, then a is equal to negative 2, meaning the system has no solution only when a is equal to negative 2. So choice A is not true. Second, the two equations have infinitely many solutions only when one is superimposed on another, meaning only when the slopes and the y-intercepts are equal. That's the slope of the first equation, 3 over 2, is equal to the slope of the second equation, that's negative 3 over 2, and the y-intercepts of the first equation, negative 1 over a, is equal to the y-intercepts of the second equation, that's 5 over 4, which is impossible because a can't be negative 2 and negative 5 over 4 at the same time. Thus, choice B is not true. Third, if a is different from negative 2, the two lines cross each other at a certain point and we will have a unique solution. Thus, choice C is true, or the correct answer is choice C. Question number 27. What is the magnitude of a vector whose initial point is at 1, negative 3 and its terminal point is at 4, 1? The magnitude of a unit vector whose initial point at x sub 1, y sub 1 and the terminal point at x sub 2 and y sub 2 is calculated by using the formula. The magnitude of vector v is equal to the square root of x sub 2 minus x sub 1 the whole square plus y sub 2 minus y sub 1 the whole square. Hence, plugging in 1, negative 3 and 4, 1 in the formula, we will get the magnitude of v is equal to the square root of 4 minus 1 the whole square plus 1 minus negative 3 the whole square. 4 minus 1 is 3, 3 square is 9, plus 1 minus negative 3 means 1 plus 3. 1 plus 3 is 4, 4 square is 16. 9 plus 16 is 25. The square root of 25 is 5. So the answer is choice C. Question number 28. Let T be a translation that takes the origin into 2, 3. Then, which one of the following has a true value of the translation T? The translation that takes the origin into 2, 3 is t 2, 3 itself. The center of a circle, x minus 2 the whole square plus y plus 6 the whole square is equal to 12 is 2, negative 6. As we know, radius will not be affected by translation. The translation affects the center of a circle. So translating the center 2, negative 6 by the translation t 2, 3 gives 2 plus 2, 3 plus negative 6. 2 plus 2 is 4, 3 plus negative 6 is negative 3. The equation of a circle, the center at 4, negative 3 and the radius r square is equal to 12 is x minus 4 the whole square plus y minus 3 negative 3 the whole square is equal to 12. This implies x minus 4 the whole square plus y minus negative 3 means y plus 3 the whole square is equal to 12. Thus, choice A is true. The center of a circle, x minus 2 the whole square plus y plus 6 the whole square is equal to 12 is 2, negative 6. Translating 2, negative 6 by t 2, 3 gives 2 plus 2, 6 plus negative 6 plus 3. 2 plus 2 is 4, negative 6 plus 3 is negative 3. The equation of a circle, its center at 4, negative 3 and r square is equal to 12 is x minus 4 the whole square plus y minus negative 3 the whole square is equal to 12. This implies x minus 4 the whole square plus y minus negative 3 means y plus 3 square is equal to 12. Choice B is also false. Choice C is also false because translation of x minus 2 the whole square plus y plus 6 the whole square is equal to 12 by the translation 2, 3 gives x minus 4 the whole square plus y plus 3 the whole square is equal to 12, but not x minus 4 the whole square plus y minus 3 the whole square is equal to 12. The center of a circle, x minus 3 the whole square plus y minus 3 the whole square is equal to 9 is 3, 3. Translating 3, 3 by t 2, 3 gives 3 plus 2, 3 plus 3. 3 plus 2 is 5, 3 plus 3 is 6. So the equation of a circle, center at 5, 6 and r square is equal to 9 is x minus 5 the whole square plus y minus 6 the whole square is equal to 9. So choice D is also true. Choice A and choice D are the correct answers. Question number 29. Which of the following function represents the graph shown in below? A. F of x is equal to cosec x. B. F of x is equal to cotangent x. C. F of x is equal to tan x. D. F of x is equal to secant x. The graph of f of x is equal to cosecant x and f of x is equal to secant x do not cross the x-axis. Thus, A and D can't represent the graph. Cotangent x is equal to cosine x divided by sine x. The graph of cotangent x crosses the x-axis at points where cos x is equal to 0, that's negative 3 over 2 pi, negative pi over 2, pi over 2 and 3 over 2 pi, and asymptotes to the vertical line drawn through points where sine x is equal to 0, that is negative 2 pi, negative pi, 0, pi and 2 pi. Hence the graph represents cotangent x. The answer is choice B. Question number 30. Which one of the following is true? A. Sine inverse of 0 is equal to pi over 2. B. Tan inverse of 0 is equal to 2. C. The domain of y is equal to tan inverse of x is negative infinity up to infinity. D. The domain of y is equal to cos inverse of x is equal to negative 1, 1. Negative 1 and 1 is excluded. In choice A, sine inverse of 0 is equal to pi over 2. Multiplying both sides by sine, we will get sine of sine inverse of 0 is equal to sine pi over 2. Sine of sine inverse of 0 is 0, which is equal to sine pi over 2, which is false, because sine pi over 2 is 1. Choice B, tan inverse of 0 is equal to 2. Multiplying both sides again by tan, we will find tan of tan inverse of 0 is equal to tan 2. Tan of tan inverse of 0 is 0, which is equal to tan 2. Again, this is false because tan 2 is equal to 0.035. C, the domain of tan inverse of x is equal to the range of x, which is equal to all real number, or negative infinity up to infinity. Thus choice C is true. D, domain of cos inverse of x is equal to range of cosine x, which is equal to -1 up to 1. -1 and 1 is included. Choice D is also false because it excludes -1 and 1 from the domain of cos inverse of x. So the correct answer is choice C. Question number 31. Which one of the following is the fourth term of a sequence cos n pi over 2? The fourth term of the sequence cos n pi over 2 is equal to cos of, in place of n substitute 4, so cos 4 pi over 2. 4 over 2 is 2. Cos 2 pi is equal to 1. The answer is choice A. Question number 32. Which one of the following is a geometric sequence? A, 8, -4, 2, -1, etc. B, 0.1, 0.11, 0.12, 0.13, etc. C, 1, 1.5, 2.5, 3.5, ... D, 0.1, 0.01, 0.0011, 0.00011, ... Choice A, 8, -4, -3, -2. The ratio of the fourth term to the third term is equal to the ratio of the third term to the second term is equal to the ratio of the second term to first term, which is equal to -1 over 2. That is, the ratio is constant. Or this sequence can be rewritten as the first term 8 as it is, comma, -1 over 2, that is the common ratio, the power of 2 minus 1 times 8, comma, the third term is -1 over 2 to the power of 3 minus 1, comma, times the first term, that is 8, comma, the fourth term is the common ratio, that's -1 over 2 to the power of 4 minus 1 times 8. This can be rewritten as -1 over 2, that's the common ratio, to the power of n minus 1 times the first term, that is g1, which is the formula of a geometric sequence. Choice P, 0.1, 0.11, 0.12, 0.13. If we find the difference of the fourth term minus the third term, that is 0.13 minus 0.12, which is equal to the third term minus the second term, that is 0.12 minus 0.11, which is equal to the second term minus the first term, that is 0.01 minus 0.1. This is equal to 0.01. The common difference is constant, so this is an arithmetic sequence. In choice C and choice D, neither the ratio nor the difference among consecutive terms are constant, hence they are neither arithmetic nor geometric sequence. The correct answer is choice A, meaning choice A represents a geometric sequence. That's all for today. We will solve the remaining questions in the next episode. Have a nice time.